Why is it necessary to talk about flammable refrigerants at all? Well, the reason is pretty simple, because there is a need to go to refrigerants with a lower global warming potential, lower GWP. Many of these refrigerants with a lower global warming potential are flammable, and due to that we have to face flammability and have to look into that. ASACOM has released a guideline which gives really good information about all that. The red link that you see here leads you to the ASACOM guideline, which you can download free of charge. Coming back to the question, are these flammable refrigerants really dangerous? Well, there is a real risk of having a flammable atmosphere when you work with these refrigerants. So the risk is real and must be respected. To make sure that you can work safe, it is necessary to follow service guidelines. It is necessary to avoid ignition sources, and it is necessary to secure a good ventilation wherever you work. To be aware of what you do, please learn about these new refrigerants, their names, their properties, and so on, and be aware of regulations and standards relevant for these flammable refrigerants and their systems. Coming back to avoiding ignition sources. When you do service, when you work with flammable refrigerants, there are some things which really need to be avoided. Hopefully it's pretty clear to everybody that an open flame, whenever you can have an explosive atmosphere, is not acceptable. So open flames is a no-go. The same accounts for smoking. No smoking whilst you do a service. Then welding, cutting. That generates a lot of sparks. These are ignition sources, so that needs to be avoided. Hot surfaces. You always can have a surface that gets hot. It's necessary to make sure that the maximum temperature of your hot surface is at least 100 K below the so-called auto ignition temperature. You will hear a few words about that in a minute. Then static charges. It is necessary to avoid these static charges. If you ask how to do that, well, establish a good ground connection. With a good ground connection, you can avoid these static charges. Mechanical sparks need to be avoided, and that can be done by using the right tools which do not create mechanical sparks. Of course, the same goes for electric arcs, because they are good ignition sources as well, and electric arcs can be avoided by using approved components only. A few words about that later on as well. Going to the auto ignition temperature. That is a temperature where material ignites itself without any additional spark. So if it's getting warm enough, it just ignites itself. And for flammable refrigerants, that auto ignition temperature exists as well. And you see here some examples of these auto ignition temperatures. You need to make sure that your maximum surface temperature of anything you work with is at least 100 K below these temperatures mentioned here. To get a bit of a feeling whether that temperature is high or not, now on the right hand side you see 3 temperatures for materials we are pretty used to: diesel, petrol and paper. They are a good deal lower than the auto ignition temperatures of flammable refrigerants, so we should be able to fulfill that requirement. Talking about components approved for flammable refrigerants, please always use components that are approved for the refrigerant you want to use. If we look at smaller compressors, you quite often find that the relays are directly mounted on the compressor. Of course, relays could generate sparks, so they are nice ignition sources. But how does it come that it is possible to mount them direct on the compressor then? Well, the answer to that is simple. These relays, they need to comply to a certain guideline, and they need to be manufactured according to that guideline. And only the relays which are approved for the compressors with the flammable refrigerants are manufactured according to that guideline. So if you look at these relays, they look quite similar to a standard relay, a relay for a non-flammable refrigerant. How you tell them apart is the code number. So please use the specific code number approved for that compressor that you are using. That means no other relay that looks similar or is an old relay from a collection box where you have collected some relays which seem to work still from an older system and let's put them on that compressor. No, please, only those relays which are made for that specific compressor. Only then you can be sure that you have a safe system. Few additional words. Flammable refrigerants, please use them in new systems only which are designed for these flammable refrigerants. That means do not retrofit systems from A1 refrigerants to flammables. The reason is that these systems are not designed for the use of flammable refrigerants. Neither the layout is necessarily made for it, nor the components, so only for new systems. Then somebody might say, yeah, but I can smell flammable refrigerants, can't I? I mean, propane, you can use that for barbecue and you can smell that, so it is possible to smell it. Well, wait a minute, because that propane that you can smell, that is only when it is used as a barbecue gas, a cooking gas, or a heating gas. The smell is a chemical that is added to the gas to make it smell. The gas itself does not smell. It's the added chemical you smell. For refrigerant grade, there is no added chemical because you want to have the gas as pure as possible. So no chemicals are added. That means the refrigerant grade propane, for example, does not smell. You need to have a gas sensor to have an identification whether you have propane in the atmosphere or not. You cannot smell refrigerant grade propane. Thanks for listening and have a good